So for part 3 of 7.2, still working with derivatives here, but now we're looking at just more than one term at a time. So with sums or differences, so there's some other term or more than one term that are going to be added or subtracted in. And so really what this comes down to is you just do the derivative of each term individually. When you run into a constant like this one, you can think of this as negative 2x to the 0 power. Well, if I had x to the 0 right here, the product rule, or sorry, the power rule would tell me to take the 0 exponent times the front. Well, anything times 0 is 0. So if you just have a constant, it zeroes out. And so here's the rule officially for that. So the derivative of a constant is 0 anytime you have a constant. But when it comes to multiple terms, with addition, subtraction, such as the case that you see right here, if two terms are being added together or subtracted, you just take the derivative of each term separately to create your answer. So if we use the same power rule that we did in the earlier lesson, that would be just doing the 2 times negative 7 to get negative 14, and subtract 1 from that exponent, and that gives me my first term. For the second term, this is x to the first, so 1 times 8 is 8, and x to the 0 goes away, so that would be our answer for that. So what you're going to see for the rest of these is just examples of as many different cases as we could find here to help you out. So if we just go on down the line for finding the derivative, then again, if I just continue to use the power rule, so 3 times 4 gives me the number in front, drop 1 from the exponent, and I get 12x squared for my first term. Just keep doing that all the way down. So 2 times negative 5, subtract 1 from 2, 1 times 7, x to the 0, and then again, if you have a constant, your constant goes away because technically this is negative 8 x to the 0 power. 0 times negative 8 is 0. So constants just go away when you're doing derivatives. Just with some of the formatting issues that we saw in the last video, you would always see radicals as rational exponents like this one. And so then now that it's formatted more easily, we could go through the power rule. So again, you got 5x to the 4th for the first term. On this one, I'm doing 1/2 times 3 and then subtracting 1 from 1/2. And so this would be an okay way to leave your answer, unless the directions specifically tell you how to write your answer. They might say leave your exponent as a positive number, or somehow word it in that form, and so you'd have to create the positive exponent on that by putting it back down underneath. It might ask you for a radical form of your answer somehow, and so we might need to get to here. But if the directions don't say otherwise, any of those three would be okay. Again, if you have a variable on bottom, you're going to want to bring that up by changing the sign of your exponent, then go through your power rule again on that one. So again, if there's no number here, we know this is the first power, times 1, subtract 1 from the exponent, so that becomes x to the 0, and which is 1. So we got that for our first term. And again, when you're doing the power rule on these, especially with the negatives, just be careful. When I multiply negative 3 to the front, so I got a negative times a negative, which gives me the positive. Then I got to subtract 1 from negative 3 to get negative 4. And one last example like that. Again, you can pause the video at any time if you want to give something a try here on your own before we explain it. But you'd want to see this as x to the 1/2. And we're going to bring that x to the 1/2 up top with the negative before we go through the power rule on that. A few more examples here. When it comes to some of the more complicated scenarios, we're going to learn other ways of doing derivatives on these. For example, there's something called the chain rule that we're going to be coming into when you have a quantity squared like this one. We have something called the product rule, where if you're multiplying something times something else, there's another way of finding derivatives. But you can always come back to these basics if you need to, like you're doing in this video. So for this one, what we could do first would be to expand the binomial. So if I did x plus 7 times x plus 7, I would get this look here. Then if I distribute the 2x to all of my terms, I can get it looking like this. And by separating all the terms individually with pluses and minuses, then you can use the power rule to find your derivative. And so this is one way to go, and one way that would allow you to use the power rule in all cases. So again, when it comes to a case like this, you'd want to expand the binomial first. You're going to want to see this as x to the 1/2 power, because as I distribute my x to the 1/2 power to all my terms, right? Remember, when you're multiplying, the rule is to add your exponents. So I'm doing 1/2 plus 2 to get that new exponent that you see here. And so same thing on that, I would be doing 1/2 plus 1 to get that exponent, and then at the end you got the x to the 1/2. But now that you formatted it properly, now you could use the power rule and do each term individually. With a case like this, again, it's just a formatting issue. We will have other ways of working with this. This is division, which in division we call that a quotient, and so we are going to have a quotient rule way of doing these things, but this is what you're seeing in this video is how you could always use the power rule if you needed to. So it just comes with formatting things properly. First of all, remember that your constant's going to go away when you do a derivative, so you can completely ignore him for the rest of the problem. But if I start by dividing the x into each term individually, remember you don't want one big fraction. For the power rule, you got to separate your terms. So in this case, this right here is just going to become 6x squared, and then right here I have -7 over x, and so I'm going to get this look here. I would bring the x up top with the -1 power. Now it is set up for doing the power rule. Pretty similar example here for the last one on number 4. So again, you might want to pause the video and give this one a try on your own. But if you were to do this one here, we would expand the x minus 2. So that's going to give you this look here. Of course, on bottom, you don't want the radical, you want the fraction exponent. And now if I were to divvy this up to each term, there's two ways you could look at it. I could either see this as x to the -1/2 and distribute that to all of my terms, where I would be adding those exponents together. Or I can see it as, if I look at it as division, then I can subtract my exponents. So for the first term, I am doing 2 minus 1/2 to get his new exponent. For the middle term, I'm doing 1 minus 1/2 to get his exponent. There it is. For the last one, this doesn't have an x, so you just simply attach this to the top with the negative exponent. And now it is set up to do the power rule. You do got to be careful. One of the mistakes that we commonly see on scenarios like this is people actually rewrite it into this format, and then they stop and they think they're done and they forget you still got to take the derivative. So now you got to do the power rule and multiply the exponent to the front, subtract 1 from your power, and you would just go on down the line and do that for each term.